Hello everyone, and welcome to another math tutorial. In this third video in chapter 2, we're going to talk about the determinant of a matrix. We're going to talk about what it is, how to find it, and also an application of determinants of matrices, leading into another application in the next video about determinants of matrices. Alright, so first let's talk about what a determinant of a matrix is. Okay, so a determinant, very simply, it's just a real number associated with every square matrix. So it's important to note that a determinant is not a matrix itself, but it's just a number, okay? And again, just to re-emphasize, only square matrices are going to have determinants. And what I mean by a square matrix, it's a matrix that has the same number of rows as it does columns. So 2 by 2, 3 by 3, 4 by 4, etc. Matrices like that. Now, when we are talking about the determinant of a matrix, we have a very unique or specific kind of notation. So let's talk about the notation for the determinant of a matrix. Alright, so when we are talking about the determinant of a matrix, when we want you to do the determinant of a matrix, we're going to denote it one of two different ways. We're either going to use an abbreviation for determinant. We're going to write DET, which I would still pronounce determinant of matrix A, or we're going to write it like this, and it looks, quite frankly, just like absolute value bars. It is not absolute value though, and we're talking about a matrix. When you see this notation, this means perform the determinant of that particular matrix. Okay, so that's what a matrix is. Now let's talk about how to find the determinant of a matrix and then go through some examples of it. Let's start off with a 2 by 2 matrix determinant. So if I've got a 2 by 2 matrix, the top row A and B, the bottom row C and D, and of course in a normal problem, those are all going to just be numerical values. The determinant is computed by doing A times D minus B times C. Very simply, what you'll see me do a lot, you'll see it on the very next problem, is we just simply take this diagonal, and I will usually draw that line there because that tells me to multiply the numbers on that diagonal, and then I'm going to take away from that the product of the numbers on this diagonal. So we're going to do a diagonal product minus the other diagonal product, and that then computes the determinant of a matrix. All right, let's go ahead and check that out with a couple of example problems. First example, we've got matrix A to be this 2 by 2 matrix. We're asked to find the determinant of A. So the determinant of matrix A looks like this. Okay, so notice the notation change. I've taken the brackets, which kind of square on the ends here, and I've just kept them straight. So that's kind of my change in notation. And all I'm going to do is this diagonal product. So I'm going to do 5 times 4 minus, always minus, and then I'm going to do this diagonal product, 2 times 3. So that's going to be 20 minus 6, which is 14. So my determinant of matrix A is equal to 14. Okay, this next problem, it's just simply presented a little bit differently to us than the last one. Here we're asked to find this. Now it doesn't say determinant, but because I see these bars here, I am supposed to know that that means find the determinant. So we're going to do this product, 8 times 5 minus this product, which is 4 times negative 6, So 8 times 5 is 40, minus, this is going to become negative 24, so plus 24, and we get 66. Or sorry, 64. And there's our determinant of that 2 by 2 matrix. Very simple computation. Quite frankly, once you do a few of these, a lot of you are probably just gonna skip writing that step and just jump right to here and then find the sum, because you can probably do these products mentally as you multiply on those diagonals. All right, I want to show you one more 2 by 2 determinant type of problem. You wouldn't think that we can mix equation solving into this, but you'd be wrong. We can certainly do it. And here's an example where I'm going to do that. The directions say solve for x. So noting that the notation here is determinant, that tells me I'm going to take this diagonal, which is going to be 5x times 2, minus this diagonal, which is going to be the quantity x minus 3 times 7, and that whole thing has to equal this determinant value of 39. Well, now we can start to solve this equation. We've got here 10x. We're going to distribute the negative right there, as well as that 7. So we're going to have minus 7x. And then the minus times the minus makes plus, and 7 times the 3 makes 21, equals 39. I'm going to combine these like terms, and I'm going to move this 21 to the opposite side. So that's going to give me 3x equals 18. So x equals 6. And we can put all sorts of different types of equations that are going to result here inside this determinant computation. For right now, we're probably going to just throw kind of some linear type equations at you in problems presented like this. Next thing I want to talk about is how do you find the determinant of a 3 by 3 matrix? There are a couple of ways to do this. And since we do the 2 by 2 determinant doing the diagonal products and finding the difference of those products, I'm going to teach you a very similar way to do this 3 by 3 determinant that's going to use diagonals. So I set up one here that's just got letters in here. Of course, these are going to be replaced with numbers when we do an actual problem. But here's the diagonal technique for finding a 3 by 3 determinant. The first thing you have to do is you have to kind of adjust the way this is written. What you're going to do is you're going to take the first two columns that you see here and you're going to write them behind the matrix. So this column A, D, and G, and this one B, E, and H, you're going to rewrite those, and now we're ready to get started with our diagonals. Now in the 2 by 2 determinant, what we did is we started with the numbers on this diagonal and we multiplied them. Now there's just more numbers, so that's okay. We're still going to go ahead and do that. I'm going to go ahead and write it down here. I'm going to multiply A times E times I. Okay. Now because this matrix is a little bit bigger than the 2 by 2, we're going to simply have more diagonals that start up here and go down through the matrix to here. So doing that diagonal first, now I'm going to shift over to this middle column. And I'm going to come down on that diagonal. And I'm going to add to this one, I'm going to add B, F, G. I'm going to do one more diagonal starting at the top and coming down. I'm going to add to this C, D, and H. Okay? So it's not just one diagonal that comes down from the top corner, top left corner of the matrix as it is in the 2 by 2. I've got all three of these diagonals that come down from the top corner. Now just like I did with the 2 by 2, I'm going to subtract. And I'm going to subtract the diagonal that comes up from the bottom corner back up through the matrix, right? With the 2 by 2 we did diagonal minus diagonal. Same idea. So now I'm going to take GEC I'm going to get the other diagonals. So there's GEC. I'm going to get this one, HFA. I'm going to get this diagonal, IDB. Okay? Essentially, it's the same process as the 2 by 2 in that you're taking diagonal minus diagonal. It's only that in the 3 by 3, there's more numbers, there's more diagonals, so it's all 3 of these diagonals minus all 3 of these diagonals, and that computes our 3 by 3 determinant. Obviously, this is not like a formula. I don't want you to memorize all of these letters here. That would be bordering on ridiculous. But we need to know kind of the process for how to do this. And so let's illustrate that process with an example problem. All right, here we go. We want to find the determinant of this 3 by 3 matrix. First step, I'm going to take these 2 columns and I'm going to write them behind the matrix. So I'm going to take this 1, 0, 3. I'm going to take this 0, 4, 5. I'm going to write those behind the matrix, and now I'm ready to start working on my diagonals. So I am going to take the 3 diagonals that come from the top down. So this 1, 4, 2. I'm going to do 1 times 4 times 2. And if you do that in your head, just do that mentally, that's okay. I'm just going to go ahead and write it all out on this first example. I'm going to add to that the next diagonal, 0 times negative 1 times 3. It's always nice when you've got a 0 in that diagonal, because 0 times any other numbers is just going to zero out this whole part. Next, I'm going to take negative 2 times 0 times 5. Okay, so that's my first 3 diagonals coming from the top row down to the bottom right. So I want to take those 3 diagonals. I'm going to subtract from that the 3 diagonals that come from the bottom up. So I'm going to take 3 times 4 times negative 2 plus, and then I'm going to take 5 times negative 1 times 1. I'm going to take 2 times 0 times 0. Okay, so we're going to work out these diagonals, which is going to give 8 plus 0 plus 0 minus, and then these 3 diagonals, which is going to give negative 24 plus negative 5 plus 0. So stick to the parentheses here. I've got 8 minus, and then over here we have negative 29. The minus negative becomes positive. So 8 plus 29 is going to give us 37. Okay, so there's my determinant of a 3 by 3 matrix. I know it looks like a very long process, but in reality, once you get the hang of it, you probably skip writing this whole first line, and you probably just do all these products really quick in your head. Just remember, you've got to keep these 3 grouped together, added together. You've got to keep these 3 grouped together and added together, and then you're going to find the difference of those diagonal sums. All right, let's take you to an application of determinants. What can we do with these 3 by 3 determinants? Okay, one application that we can use determinants on is finding the area of a triangle. And I know what you're thinking. You're probably thinking, I know how to find the area of a triangle. The area is 1/2 times its base times its height. You know, and that works for sure if it is a right triangle. If it's not a right triangle, There are some trigonometric techniques that you can use to find the area of a triangle, but it's possible you haven't studied trigonometry yet, and if you haven't, then you don't have access to those techniques yet. What I want to show you is a way that we can find area of a triangle, any triangle. It doesn't have to be a right triangle, it can be any kind of triangle, provided that we can place the vertices of that triangle on a coordinate plane. If we can do that, if we can place the vertices on a coordinate plane, then it's not going to matter if we can find the lengths of any of the sides of the triangle. A 3x3 determinant will compute the area. So here is your area formula with 3x3 determinants for the area of a triangle. Okay, so all you're simply going to do is take a 3x3 determinant. Your first two columns here are just the points of the vertices, and then your third column is just simply a column of ones. The 1/2 is just kind of a remnant of the 1/2, part of the 1/2 base times height formula. You're going to use plus or minus depending on the sign of the determinant. Okay, you want basically, let's just write it like this. You need to force the area to be positive. Okay, so if this comes out to be, well, let's just do this. If this comes out to be a positive number, then multiply that positive number times positive 1/2. That's going to make it positive. But if this 3x3 determinant comes out to be a negative number, then you're going to multiply by negative 1/2 so that this area comes out to be a positive number. We're talking about area. The area inside this triangle has to be positive. So the plus and minus is a choice that you're going to make based on what happens with this right here. Okay? I've got one example problem to do, and that's going to wrap up the notes on this video. We are asked to find the area of the triangle given it has vertices at, we've got 3 coordinate points. Now you don't really need a graph to do this. I only put it here so we can just kind of see the problem we're working on. But with just the points, that's enough to jump right into that 3x3 determinant setup. Well, let's go ahead and plot these real quick. So the first point's at -7, -5, which is there. Next point is at -2, 8. Next point is at 6, -2. So there's our triangle. Try and make this as straight as possible. Okay, and we want the area of this triangle. All right, so let's set up our 3x3 determinant that's going to compute area of this triangle. The area is equal to plus or minus 1/2 times. Now we're going to put these coordinate points inside the 3x3 determinant. The order that you put them doesn't matter, so I'm just going to take them in order that they're given. Take -7, -5, and then put a 1 behind it. I'm going to take -2 and 8 and put a 1 behind it. I'm going to take 6 and -2 and put a 1 behind it. And that's it. That's what I'm going to compute to find the area of this triangle. Now, as we talked about in our previous example with 3x3 determinants, we're going to start by rewriting the first 2 columns behind this matrix. So here's my -7, -2, 6. And then here's my -5, 8, and -2. So I'm going to work this out kind of piecewise. For the time being, I'm going to forget about that plus or minus 1/2. So let's just work on this part right here. Okay? I'm going to start with this diagonal, which is -56. I'm going to go ahead and just do the products as I go, like I would in a regular problem, and not write down every single step. Plus, and then this diagonal It's negative 30 plus this diagonal multiplies to positive 4 minus, then I want this diagonal right here, which is 48, plus this diagonal, which is positive 14, plus this diagonal, which is positive 10. All right, so we've got in this set of parentheses right here, this is negative 86 plus 4, so we have negative 82 minus, and then over here, this looks like 72. So I got negative 82 minus 72, which is negative 154. Okay, so that's just the 3 by 3 determinant. Now don't forget, in front of all this, we have to now multiply, or what was there, was this plus or minus 1/2. We just ignored it for now, but it's there. Still there. And then right down here, it's still there. And because this is negative, I now know I need to multiply by negative 1/2. So now I've made the choice between the plus and the minus. I'm going to choose negative because I want the negative times the negative to become a positive number. So multiplying half times 154, or doing 154 divided by 2, I get 77. And I can put some units on this. It's area, so I could say units squared. And that's the area of this triangle done with 3 by 3 determinants. This is a great tool to have when you're finding areas of triangles. You might encounter something like this on like a standardized test like an ACT or something, and it's a way to bypass needing to find lengths of sides of triangles. It's a way to bypass needing to find angles inside, to use some trigonometric means to find an area. If we know how to do this 3 by 3 determinant, and then later on, when I teach you how to do a lot of this on the calculator, it makes this even that much faster. So that's all I've got for you for this video. If you have any comments or questions, please drop them in the comment section below. If you found this video helpful and want to support the channel, I encourage you to give it a thumbs up. Thank you for watching all the way to the end, and as always, I will see you in the next video.